Good evening. My name is Simon Ittman. I studied computer science at Hochschule München, and I write my bachelor thesis about an alternative architecture for websites based on WebGL. Here, first the agenda. In the first part, I tell you something about what it is. The second part is the comparison with other UI frameworks. The third point is a little bit about the architecture. The fourth point are the graphical concepts. The fifth point, performance optimizations. And at the end, I got some measurements. Okay, this is the first point. The alternative architecture is UI framework, a JavaScript UI framework, and you can use it to create three-dimensional websites, and you can do animations and everything. Here I got some example for some element. So maybe you could make something like this. It's very easy. Then I got, or maybe you can make some advertise. You have an HTML page and you want to do just maybe some cube with advertise. Get another example. Maybe it can look like this. I don't know, you can put it into your web page. Okay. Summarizing up, it's a JavaScript UI framework. The big point are the three-dimensional objects. Maybe you can build the whole page three-dimensional, or you just use a two-dimensional HTML page and use some three-dimensional objects. It's up to you. It should be very easy to learn and very easy to use if you often make JavaScript and you know the web technologies. It's based on WebGL. Up to now I use Three.js. Maybe in a next update it should be with a native WebGL. This would be a little bit faster. And in some points it has better performance than normal frameworks based on HTML. The first example is the nesting of elements. That's like you know it from other frameworks. It's just here the small cube, the blue cube is element 2, and the other cube is the red cube, element 1. And you can nest them with the append to command. That's like you know it. You have two element categories. It's simple elements and complex elements. Simple elements is like the rectangles we've seen before. They can be nested, and they're like HTML elements a little bit. And they have all basic functionalities like wise, high, and so on. And on the other side, on the right side, you have complex elements. A complex element, I'll show you an example later. It consists it's built out of simple elements, and they have individual functions. Here's some example. The simple element, just a rectangle, and the complex element, it's not styled so well, but it's a three-dimensional object. Now I'll make the comparison. I choose XJS from Sencha. I think it's one of the biggest UI frameworks. You see from the code, it's nearly the same. It's the attributes and the properties, they are like you know it from CSS. I think it's easy to use. You can choose percentage values for the wise or the high, or you can take it in pixels like you want it. Here are the pictures. This is on the left side the XJS panel, on the right side the three-dimensional panel from the alternative architecture. Then I tell you something about the markup and usability. The markup is what we've seen before, the code. It's oriented on other frameworks. It's like you see it's nearly the same like in XJS, a little bit different commands, but it's really oriented on other frameworks. The properties, most of them are like in CSS, so I think if you're good at CSS, it's easy to use and you can understand it very fast. It's object-oriented. The consequences are, I hope it's easy to learn and easy to use. And the usability, the part downstairs, the behavior is most of the time it's the same like you know it from HTML and CSS. It's like you can use pixel values, percentage values. That's the consequences, easy to learn. And the other point is if you're able to, you can use computer graphic concepts. There's the consequence. You don't have to just, if you're able to, you can use computer graphic concepts. And then you can build more complex effects, animations, or elements. The technical difference on the left side, it's just how a general JavaScript UI framework works with HTML. And on the right side, the alternative architecture. The markup is nearly the same, depends on the framework, but it's easy. Create rectangle, it's nearly the same. The generated code is on the left side. On normal JavaScript framework, it can generate HTML and CSS. The alternative architecture is generating 3D raw data, and if you need it, custom shaders. And the next point is the rendering engine. Here you see a normal framework is using, depends on your browser. If you use Firefox, it's Gecko, the rendering engine, and so on. In the alternative architecture, this is done by the OpenGL. It's called WebGL, and it's using the OpenGL graphic library. And you see in the end, the graphical presentation is both just a rectangle. So for the user, it's not really a difference. You have the same markup, nearly the same markup, and you have the same graphic presentation. So the difference is just the part between. Okay, now the architecture. First, the interfaces. The first is the user can create an object. That's part one. The object is managed and from the alternative architecture, and it's listening to events, resize, or so on. Then it's generating, now it's generating 3 objects. Maybe later it would be a native implementation in WebGL. Then it's not using 3JS. I think you know 3JS? That's a JavaScript graphic library. In the next part, 3JS at point 4, 3JS is making out of the commands, making native WebGL commands and giving them to the WebGL, through the next interface. WebGL is drawing the elements, and at the end on the screen you can see the objects. Now the initialization of the framework, it's like you know it from other JavaScript frameworks. You integrate some JavaScript file in the main page. That's the main module. It's very small. It has just the most important functions. It's maybe exception handling, logging, and so on. The additional libraries get reloaded. Later, just if you need them, it's like on require.js. You just load the libraries you need, really. Some global instances, maybe util, is created global. Lots of functions are using util functions, so it's just one global object. So it's better for your memory, you don't need so much memory. And at the end, if the initialization is finished, the already function is called, like you know from jQuery, the already function. The next thing, it's using the on-the-fly technology. This means just the settings of the user. These are the red ones in the middle. Just these settings are in memory. All other values get calculated just in time when they need it. Here's the example: is the renderer wants to paint element 1, and he needs the real width in pixels. He needs the real width. So he's asking get width element 1. Element 1 don't know. Element 1 just has 50%. So element 1 has to ask element 2. You see here on the right side, you see element 1 is the green one. And it's the parent element is the blue one, element 2. So it's asking element 2, get width. Element 2 just knows 50%. Ask the body, and the body has a fixed width. Maybe it depends on the window size, or it's a fixed width. And so it returns 200 pixels, get broke down 50%, 100 pixels, and so on. Here the properties, the positive things are you have no redundant data, you have a very low memory consumption, and the values are always up to date. You never get problems. But the negative part is your CPU has to calculate a lot. Now I come to the graphical concepts. I got 3 layout types you can choose. First is the fixed layout. This is just if there's an overflow, the browser will give you some scroll bars. Then the elastic layout. This is scaling down elements. It's making the size a little bit smaller so that everything is on the screen. And the next thing is the fluid layout. That's the basic thing you know from HTML. You can set min-wise, you can set percentage values, and so on. Some examples for this. First I show you the elastic layout. This here just some colors. And if I make it down, here you see all elements getting smaller or getting bigger. The next thing is the elastic layout. Made a mistake. The fluid layout. You see the 4 cubes. The cubes have min-wise, they're fixed min-wise. And so if I make it a little bit smaller, you see the space between is getting smaller. Here, but in the end, you see that the cubes don't get smaller, just the space between. Okay, the next thing is it has a 3-dimensional layout. Normally, you know, from HTML is a 2-dimensional layout. You can nest elements in the X direction or in the Y direction. And here's the special thing, you see it in the left picture. You can also nest elements in the Z direction. Here you see the gray element in the back. It has a Z layout. That means all child elements get next to each other. So if you append a new child, it gets next to each other on the x-axis. The red elements are child elements of the gray element. And the red elements have the Z layout. And the 3 cubes, just make cubes to see it better. It can also be rectangles. The cubes are appended to the red elements, and the red element has some Z layout. So they come in front to you. You see on the right side is an example from the architecture, how it could look like. The next point are the camera perspectives. I know it's possible in CSS, you can also choose some camera perspectives, but I think here is a little bit easier. You can just say for the whole application and give the whole application one camera perspective. On the left side you see the orthographic camera. There you can't see the Y's or the depth, you can't see nothing. And on the right side the perspective camera, there you can see it. It's just like, if you look in real life, you look with a perspective camera. So if you make something with 3-dimensional elements or animations, you should use the perspective camera. Now I came to performance. I got some module, it's called Element Managers. The idea behind is optimization of the rendering loop. The rendering loop is, you know, if you're making games, you always have a rendering loop. It's a loop, it's running all the time, as fast as possible, and this loop is always repainting the picture. So, and it should happen very often. If you want to get a good animation, it looks good for the user, it should have lots of rendering loops, or not lots of the loops should run as often as possible. And so the idea is, because the browser is not so fast, I have different rendering loop implementations, and it's up to the user to choose this implementation which is good for his application. You can't say generally, okay, this is the best one, this is not the best one. You have to depend. The three most important, it's the default element manager. It's calculating all elements in every cycle, and it's redrawing them in every cycle. So if you make an animation, you should use it, because you have to repaint the picture as often as possible. But it's not so fast. If you have lots of elements, it's getting very slow, the whole application. The next thing is the render on change manager. It's checking in every rendering loop, in every cycle, it's checking all elements if something has changed, and only if there was a change for one element, he's repainting the picture. You should use it maybe for static pages. There are not lots of changes, so just when there's a change, there's a redraw. And the next point, and the most interesting point, is the visible element manager. He's checking in every cycle if something has changed, but he's only looking at the visible area, the area you can see on the screen. If some elements are not on the screen, he's not looking at these elements, he's just looking at the important elements. And he's redrawing if something has changed. You can use it for tables. I have an example later. Here is the explanation. You have the red area is the screen, you can see. The 75%, this is the scroll bar position. This is a table with some elements. And the scroll bar is on 75%, so you can just see element 4, 5, and 6. So the manager has just to calculate the 3 elements, just if something has changed in these 3 elements, or, yeah, that it is.
Simon, you have 3 more minutes.
Okay, I got here is the table, and you can see here, you can see if I scroll very fast, he has to rebuild the elements. I think with a better implementation, it will get a little bit faster. Okay, now the measurements, the last point. Here I have the adding elements. You see on the y-axis, it's the number of elements, and on the x-axis, it's the time. And you see HTML is the blue line, and the visible element manager is the red line. So you can see it's faster with adding elements. And the big point at the visible element managers is you can build very big tables with thousands of elements, and it's no problem because it's just looking at the visible area. Then the next thing is the removing of elements. Here you can see HTML can remove 80,000 elements in a little bit more than 1 second. And the visible element manager, the red line, can remove 100,000 elements in maybe 100 milliseconds. It's really fast. It's just because he has just to throw away the pointer and repaint the picture, and then it's done. And the last thing is for animations. I compared CSS with HTML and WebGL. And here you can see on the y-axis, it's the frames per second. They should be more than 20. If you're under 20 frames per second, the animation is not good for the user. It looks not like perfect, it's a little bit in steps. So you should be over 20. And you see the HTML is for 200 elements, it's over 20, and if you have more than 200 elements, it's going under 20, so it's no good animation. And you see WebGL can make maybe 1,500 elements with more than 20 frames per second. Okay, that it was. Thank you for your attention.